the two kind of loops we're going to talk about today are the while loop and the do while loop. All right, so what's a loop allow you to do? It allows you to repeat things. So what happens here in a while loop, we're going to have while, and then we're going to test something. So kind of like we did in an if statement. You might have something like while x is less than 10. And then you have a curly bracket. And then as long as x is less than 10, it's going to keep doing whatever's inside these parentheses over and over and over again. When will it stop? There's two options. It'll stop when x is no longer less than 10, or, as it says down here later on, you can throw a break into the middle, and then that'll kill it. So we might have something like here, while x is less than 10, let's up here initialize x. We'll have int x equals, we'll start it at 0 perhaps. And then we might have while x is less than 10, see out x, and line, and then x equals x plus 1. So there's a very, very simple while loop. What would this while loop do? Well, is x less than the number 10? Yes. So it's going to come into here, it's going to see out x. So what's it going to print? 0. So it's going to print 0. And then what happens? X is now the number 1. No, x is a variable, not a... I want to print the actual number, not print the letter x. Yeah. All right, so anyway, it prints 0. X is now the number 1, and then it comes back up here again and it checks it again. Is 1 less than 10? Yeah, so it prints 1, and then x becomes 2, and it goes back up here. Is x less than 10? Yeah, so it's going to print 2, and then it's going to print 3, 4. So what will happen, it'll keep going, keep going, then it'll get to 9. Is 9 less than 10?
Yes.
Yes. So it's going to print 9, and then it's going to say x is 9 plus 1, so x is now the number 10. It's going to come up here, it's going to say, is x less than 10? No. So then it jumps to this parenthesis, and it will do whatever comes after that parenthesis. It'll just jump out of the loop once it gets there, and keep going for whatever commands come next. Okay? So, what might you use this for? You might use it for counting. You might use it for, it's kind of a pain in the neck to run your program once and get the answer and then go debug, start without debugging and run it a second time to just type in different numbers. And then have to run it a third time because the teacher makes you run it like 5 times. That's kind of a pain in the neck. So how might you use a while loop to make your program run over and over and over again? Do what? All right, so you're going to use a while statement, and you got to think about where you want it though. I don't think it accepts an infinity symbol. Well, for this program, if I simply wrote, if I used this, x is greater than or equal to 0, then that loop would run forever, wouldn't it? It would never, ever, ever stop. So I could put a break in here somewhere and say break. Well, usually you would have an if statement. If x equals 10, break, and that would kill it out. In general, you want to avoid that, though. You don't want infinite loops. Those are bad things. Or if you just put the number 1 in there, I think it would keep going forever. I think 1 is true and 0 is false. Yeah, I think if you just put while and then the number 1, it would run forever. Okay, that's an interesting question. Her question is, with a while statement, is there a way to program it to run exactly 5 times? And the answer is yes. Basically, what you have to do is set up a counter and have it count when it has run 5 times, then tell it to break. But what you're describing, if you want something to run exactly 5 times or exactly 100 times, you would usually use a different kind of loop called a for loop. And we will get the for loops in the not too distant future. So if you know exactly how many times you want something to run, that's usually a for loop. A while loop is usually set up for you don't know how many times you want it to run. You want it to keep running until some condition changes. Now, speaking of infinite loops, like this would be an infinite loop, that's a bad thing. So I have a funny story for you. When I was a freshman in college, I went to SUNY Potsdam, and I was a computer science major. So I was taking computer science programming courses just like you are, except we were using Pascal. I don't think C existed back then even. We were using Pascal. Anyway, we didn't have personal computers like you have today. The college had a mainframe. Anybody ever seen a mainframe? You've heard that word before. All right, so this was one computer. This one computer would fill this entire room, and probably then some. It was huge. It was a Burroughs 80-something mainframe. I forget the exact number, but it was monstrous. This one computer ran the whole campus. And this one computer was probably not as powerful as the cell phone you have sitting in your pocket at this point in your life. Okay? When we got to while loops, our instructor did not properly beat into our heads to watch out for infinite loops. And so the first program that we wrote that had loops in it, a whole bunch of us, the silly freshmen, we wrote infinite loops. And so here you had 100 computer science majors all trying to run their program all at the same time, and they all had infinite loops. Guess what happened? We crashed the mainframe. And when I say crash the mainframe, I mean we crashed it. And it's not like a PC. When you crash a mainframe, you can't turn it off and wait 5 seconds and turn it back on and it reboots. They had to fly somebody in from Burroughs to figure out how to shut this thing down, wipe its memory, and then reboot it. It took them like a week. They were a whole lot mad at us. And we said, well, blame the teacher. He didn't tell us to avoid infinite loops. It's his fault. Well, then I'm going to tell you how old I am, so that's not good. This was fall of 1985, is when I was a freshman in college. I'm only 2 years older than you. Thanks, that makes me feel good. My sophomore year, I actually rented a PC. That's when PCs started becoming available. And then I got to assembly language, and that's when I decided I didn't want to be a computer science major anymore. So anyway, that's a whole different story. I'll tell you another funny thing, though. As a computer science major, we ran on this mainframe, and so, like I say, the whole campus used one single computer. So we were very limited. In a week, I could only compile 10 times, and I could only run 5. So you know how you guys will type like 5 lines of code, and then you'll do a debug and see if that 5 lines is working, and then you do 5 more lines of code, and you debug and run it to see if it's working? We could not do that. You had to be very, very careful about writing your whole program at once, checking it very carefully, making sure you didn't miss a semicolon somewhere, because missing one semicolon cost you 1 compile. And you only got 10 all week long. So we had to be very, very careful about our programming. We couldn't just keep compiling over and over again and fix one error at a time, one line at a time. Yeah, we were rationed. That's exactly right. And basically what it was is, like I say, this one computer ran the whole campus, so they couldn't have the students hogging all the resources and then not be able to do the other things that needed to be done.
Did your teacher ever give you like more than one
We usually only had one a week, but the programs were usually quite a bit longer than the programs you're writing. So you're not actually a computer science major, you're in engineering, so you're just learning the bare bones of programming. When you're a real computer science major, you write much longer programs. So, yeah, it was tough back then. I mean, we had to walk uphill in the snow every day. Both ways. Well, if you've ever been to Potsdam, it does snow there, by the way. It's cold up there.
There was one good thing. Like candy bars, like 2 cents.
Yeah, candy bars were cheap. That's right. Candy bars were a quarter back then, actually. They weren't 2 cents. The vending machines, candy bars were a quarter. Now they're like $1.25 or more. You're right.
Yeah.
Sodas, a can of soda was also a quarter. Gatorade was not a thing back then. Yeah. Soda, a can of soda was a quarter back then. Anyway, so back to while loops. Enough of my crazy stories. So basically, in your program, I'm going to skip a few steps here. To get a program to run over and over again, you're going to have your void main, and then your parentheses stuff. You're going to want, at the top, you're still going to want to see out your header. So I'm not going to write all the stuff you would have there. You only need that header to print once, don't you? You don't need that you don't need that header to print every time you run the program. So you would see out your header still. Of course, that's legal code now, I suppose. You have your header. Then you would still declare your variables. Like so. You only need to declare your variables once. Then probably at the point where you start asking the person to input stuff, that's probably where you want to start your loop. So you probably want to see out directions to the user. This program will do stuff. You only need that to show up once, generally. So probably right about here is where you actually want to start your while loop. Right at the point where you're first telling the person, all right, now enter the 2 numbers, or type in the name, or whatever you're having the person do. That's probably where you want to put your loop. And here's the way I usually do it. I usually declare another variable called char. Char loop equals yes. And then I'll start while loop equals yes. Oops, single quote there. And then I have a parentheses. And then this is where the rest of my programming stuff goes. So this is all my tell the person to enter the 2 numbers, and then you add the 2 numbers, or whatever you're having your program do. Most of your program block goes in here. Now, here's where my teacher did not do a good job. You need to have a way to end this loop. So way down at the bottom somewhere, after you've done all your other stuff, you're probably going to want to have a cout, run again, Y for yes, N for no. And then you'll have the person cin loop. So if the person types a Y, then it'll run again. If they type anything else, it really doesn't have to be an N. If they type anything else in the whole world, the program will stop. And that's the mistake we made, that we forgot to put in a thing that got us out of our loop. Okay? So that's kind of the basic structure you're going to want for a lot of your programs now. You're going to want a while loop in the middle that allows you to run your code over and over and over again, so you don't have to keep doing the start without debugging, and then it runs, and you type your numbers in, and then it dies, and then you run it again, and so on and so forth. Okay? Is that clear? Ish? Makes more sense when you actually start writing a program. Correct. All right, so that's a while loop. What if I forgot to put this here? I put char loop equals quote y. What if I just What if I forgot to put the equals quote y, and I just put char loop right there?
And it wouldn't run the while statement because you would not be.
What kind of error would I get? No,
That would be a logic.
that would be a runtime error. The program would actually crash right here because it's trying to compare loop to something, but it doesn't know what loop is. You haven't put anything in there for it yet. So if I left off that equals y part, I would get a runtime error when it got to right there. It doesn't know what loop is. What's that? Try and catch. I'm not sure what a try and catch statement is. What's a try and catch statement?
Makes it more robust to runtime errors. So it will try first and it sees that it will have a runtime error, then it won't do it. Program. It's a thing in a couple other languages.
Not that I'm familiar with. It also could be different compilers might have that. So we're using the Visual Studio 2017.
Right.
That might not have that feature. Some other software that has a compiler might have that feature in it. I'm not familiar with it. So it would be nice if it tried to fix it and keep running from there, but it doesn't do that, as far as I know. All right. Anyway, a similar kind of loop is called a do-while loop. So for a do-while loop, you have the word do right at the beginning, and then you put a parenthesis, a curly bracket, and then you have a bunch of statements inside the curly bracket, and then at the end you have while, and then you test something, and then you put a semicolon. So notice a slight difference here. You do not put a semicolon at the end of the while statement up here, but you do put a semicolon at the end of the do-while loop. That's an easy mistake to make. No semicolon for the while loop, yes semicolon for the do-while loop. So a do-while loop does almost exactly the same thing as a while loop. The difference is a do-while loop, you're guaranteed it's always going to run the first time. Because it says do, and then it does these things, and then it tests way down at the end. Where a while loop tests at the beginning, does a bunch of stuff, and then tests again. So that's the big difference between the two. A do loop will always run at least once. A while loop might not run at all. How could a while loop not run at all? If the criteria from the very beginning was wrong. So for example, if my while loop was int x equals 0, while x is less than 0, do some stuff, this loop would never run because x is never less than 0. So these statements would all be completely skipped. Like I say, a do statement, on the other hand, it's always going to run once, and then at the end you'll have a test. So that would be another way to write a program that repeats over and over again. Instead of having a while loop here, maybe do a do loop so that you know it'll run once, and then again at the end you would need a do you want to run again, yes or no, and then you would have while loop equals yes at the bottom. So you could do it either with a do loop or a while loop. Probably if I'm running a program like this, I would actually use a do loop because I do want it to run at least once. But a while loop will certainly work, and you can do it either way. Questions about that? Right, so on a do-while loop, when you have the while statement, there's a semicolon right there. When you're just using the while loop, notice there's no semicolon right there. So the lines look exactly the same. While, parenthesis, test expression, close the parenthesis. No semicolon when you're using a while loop. Yes semicolon when you're using a do-while loop. And it's very easy to forget. It's a very common mistake is to put a semicolon right here. That's the more common mistake. People don't usually forget to put one. They usually put too many in this case. And I'm seeing that sometimes in class and lab. I'll see people do like if x equals 10, and they'll put a semicolon right there. You don't put semicolons at the end of if loops, or at the end of if blocks. So it should be if x equals 10, x equals x plus 1, the semicolon goes there.
How would that affect the program?
How would it affect the program if you put the semicolon right there? It would say if x is less than 10, it wouldn't matter if it's true or not, it thinks that's the end of the loop. So it will then run the next line no matter what you do. And it will do the same thing with a while loop. If you put the semicolon right there, then it thinks that's the end of the while loop. So it's going to run the next statement no matter what. Not what you want. Okay. All right, we talked about this. We used the word break in our switch statements. You can use the word break inside a while loop or inside a do while loop. And usually it's in conjunction with a test. So you might have to, if you're like dividing things, you might want to have a test to make sure the bottom is not 0. And so you might have an if bottom equals 0, then break. You got to get out of that while loop because you can't divide by 0. That's coming up next somehow. So every now and then you put a break in there if you want to test something different. Not commonly used in this class, but I don't know, something might come up where you want it.
So if you're do like a piecewise function or something, that would be
Possibly, yes, if you're dealing with a piecewise function. All right, what's next? All right, so it says, write a program that will allow the user to multiply two numbers and repeat with as many pairs as wanted using a while loop and a do while loop. All right, so basically we're going to write a program. We're going to write it twice with two different kind of loops. Turn the screen back on here. All right, so I filled in a little bit here. I've got the include IOStream, the using namespace, and the void name. All right, so what would I do first if I'm writing a program that will multiply two numbers? Documentation. This program will do stuff. All right, so I got it up there. This program will, ... You'll fill that in. You can write it down on paper if you want, or when I'm done, I will post this on Blackboard. I post these programs on Blackboard. What's next? A header. See out. Header. So I'm cheating. I'm not doing the whole header thing that you will do. You will do the whole header thing.
No, it's not.
It's not okay? Too
I
bad.
don't know what day it is. We will do.
Right. We'll live without it. All right, what's next? Variables. What kind of variables do I need? Am I going to use decimal numbers? I don't know for sure, so it would probably be safer to use decimals. All right, so I need a couple float variables. Num1 and num2. Okay. Never go wrong with those. What else do I need?
Character.
I need a character to control my loop, don't I? So I'm going to do char loop equals yes. All right. And of course I should be documenting as I'm going. So there's my documentation, you see, there it is. So I will document this one. Used to control while loop. Okay. What's next? Void main. I already got void main.
Use it. Right the wow.
See out. Explain to user. Okay. Again, I'm not going to write the whole words there. You know what the words are. All right, and then I think I want to set up my while loop. So I think I'm going to have while loop equals yes. I need another equal sign. Ah, very good. I did not do that on purpose. See, that happens. Okay, so what do I want the person to do? I want to tell the person to enter two numbers. See out. Enter two numbers. Got my quote. CN, the two numbers. I'm still seeing a lot of people on CNs do that. They're putting a comma in between num1 and num2. When you do a CN, it's never a comma. What should it be? Always greater than symbols. So it should be num1 double greater than num2. The only time you use a comma between things is back up here when you're declaring the variables. When you declare the variables, you put a comma between them. When you're reading them, it's the greater than symbols. All right, see out. The product is num1 num, slow down, times num2. All right, so if I were to run that right now, what would happen? It would go forever and ever and ever. That's our infinite loop problem. That's a bad thing. Right, and unfortunately it doesn't crash a PC usually. It keeps running and running and running until you hit close to that little black box and it'll stop it. Good. Let's get us right over that. All right, so I need to ask the person. I'll say continue. Or run again, maybe? Run again. Type Y for yes and N for no. And CN.
Yeah, is the loop case sensitive?
Is the loop case sensitive? That's a wonderful question. Yes, it absolutely is.
Why not just put a Q upper and then so that all those like
Say that again.
if I go to C++ with called Q upper and find a variable and whatever it's put in and then it will automatically become uppercase or lowercase.
Okay, I wasn't familiar with that one. What I would have done is I would have come up here and said, or where's that button? Okay. Or loop equals little y. That's how I would have fixed it. You guys won't let me get away with that today, will you? I won't let you get away with it either. That's right. That's how I would have fixed it. I wasn't familiar with that command that converts upper to lower and lower to upper. Those are absolute value symbols, yes. Two of them is the word or in C++.
In the case of the states program, that made it a lot clearer.
That's true. You didn't have to case upper and lower. You can convert everything to one or the other. All right. Let's run it. See if it works.
Oh, here we go. Mainframe.
Header, explain to the user. Enter two numbers.
12.
Wow.
12.
We
28.
And 28. Oh, you want to see too?
A little serious. Oh wow, look at that.
There you go. What's 12 times 28?
A relatively large number above 200.
Apparently the answer is 336.
I like that.
Run again. Type Y for yes, N for no. Y. And it does run again. So enter two numbers again.
I like that.
7.
7. 0.7. just to make sure our decimals were working there.
Really big.
Do a really big one. All right, give me really big. 987654321.
Yeah, there we go.
1, 2, 3, 4, 5, 6, 7, 8, 9. Product is 1.21933 times 10 to the 17.
Sounds about right.
I thought so.
Yeah, it looks good.
If you didn't want to use scientific notation, how would you tell it not
Such a good number.
For a number that big, I don't think you have an option.
I think that's bigger than a float.
And I think it's actually bigger than a float can handle.
I think it was bigger than a float, you wouldn't get a value. Just some kind of rings.
You'll get a number, but it might not be the right answer. That's what it'll do quite often. If you go outside of range,
Right, it'll give you negative something rather than positive something.
sometimes it'll do that. Sometimes it'll actually give you an answer.
Let's go bigger.
What have we done?
I don't know. We broke it.
We created an infinite loop somehow. But fortunately, the way to fix it on here is to go like that, and pretty easy.
So how did we end up breaking our normal loop?
I don't know. Let's try that again.
That was really cool. We just broke it with what the all see out.
That time it said the product was infinity.
Where did we get that happen?
When did we program it in
Hey,
Infinity?
it seems.
We didn't.
Okay, that's a little creepy.
Oh, and then at the end, put point one. Yeah. Yes.
I don't know what the difference is.
It's saying at the end of the product.
What happens if you get a CMAP?
That shouldn't matter. It doesn't need CMath to multiply.
Operating disease stuff.
So I don't know why sometimes it's giving me an infinite loop and sometimes it isn't. That's interesting.
Why does it tell you? I can't even fathom why it tells you how it does infinity.
It doesn't really, because the answer really isn't infinity.
It's higher.
It's just higher than anything that it can handle, so it tells you the answer is infinity.
Just stop caring.
It stopped caring. Yeah, that's
It's
good.
like an integer.
That's the difference.
Like it's one.
That is an example of what's called overflow. Yes, it is. When you've given it numbers bigger than it can handle, that's an example of overflow. And as you can see, it does cause issues.
So which one's the larger, like a double or a float?
Double is larger. Double can handle bigger numbers and smaller numbers. All right, so very quickly, how would I change this to a do-while loop?
But if you move your while expression down the bottom,
My while moves down to the bottom,
you put a semicolon after it,
and I put a semicolon after it.
and you put do up at the top.
Okay, just a minute, you're getting ahead of me. I put do up here. Do. The other thing that's different is I would not need to initialize the variable loop because it's going to do it once anyway, and then it'll ask me run again, and then I'll type yes or no in there, and then it'll check down here. So if you use a do loop, you don't need to initialize your variable originally. Does it hurt to initialize it? Of course not. Wouldn't matter at all. But you don't need to because you read before you test. With a while loop, you test at the beginning, so you have to tell it, I want it to run once, so make it yes. So that would be the do loop there.
Let's try it.
Let's try it. All right. You go.
Let's try and break it.
Do 10 digits of pi. 3.141592679835542. I just started making up numbers after a while there. I don't know. 90 digits of pi. The first 6 or 7 are right. I just started making up numbers after that. And then 2.1718. Anybody know what that number is? Approximately? That's approximately E. So pi times E is approximately 6.82287. Want to run again? No, because it's time to leave.
No, yes.
Yes? All right. One more time, just for you.
We want to break it.
We want to break it, right?
Yeah, there's a whole bunch of nines. And
Negative, a whole bunch of 9s.
Oh,
didn't even have to hit another number. It broke it right away.
You don't deserve to run me this time.
The dude can't handle it.
You can't